Today in CT 144, which is our photovoltaic class, we are going to do an experiment on temperature and the impact that it has on the performance of a PV module. So right here we have a SunPower 327 solar panel, and as you guys remember from class, this is the nameplate data down here, and so you can see that it's a 327. The voltage, the VMP, is if it was connected to the inverter, and the IMP is the current that you would have if it was connected to the inverter and had a load on it. The open circuit voltage, that's the one, that's the max voltage, right? And that's when it's not really plugged into anything. And sometimes that's going to happen, like perhaps when the grid goes down. And so for safety's sake, we have to know what the open circuit voltage is for the building and safety folks. And the same thing here with the short circuit current. That's the max current, and that's when it's short circuited, which we're actually going to do during our experiment. Okay, so if you guys remember, all of those numbers are based on standard test conditions. In fact, we can come back in here and you'll notice on the nameplate data, it tells us what it is. That's 1,000 watts per meter squared, and the big impact is going to be on amperage. And then right here it says 25 degrees Celsius. So what we're going to do today is we're going to look at what happens when it's not 25 degrees Celsius, because that is the same as 77 degrees. I made a little table here, and it just kind of converts Fahrenheit to Celsius. And so you'll notice that these are the Fahrenheit numbers here, and 77 degrees Fahrenheit is the same as 25 degrees Celsius. And so what we do with the temperature is, when we originally tested the panel, we said, okay, it's 77 degrees Fahrenheit, 25 degrees Celsius. This is what it will produce. But what we're going to find out is what happens when it's different. So then in order to do that, we're going to use our meter, and we're going to test two different modules. And so I have one here, and if you notice, it's in the shade, and in a few seconds we're going to go over to the one that's been sitting on the roof for a while. So come on with me. We've got this, it's the identical panel, and I kind of checked it a few minutes ago, and it was about 40 degrees Celsius. In fact, I think it was 45, and then the wind came up. And now I'm getting a really high temperature. Okay, I'm getting 52.0, 51. And as the wind comes up, it'll actually cool off the panel. So we're looking at about 52, 51 degrees Celsius, which is a lot hotter, right, than 25 degrees Celsius. So from our class, you guys know that we expect the voltage, this is going to be open circuit voltage, it should be 64.9, I believe. That's the open circuit voltage that says on the back. But because it's hotter, we expect to get a lower voltage. And then we're going to check our math to see if it works. And it does, of course. So I got my meter, and I'm going to set it at volts, DC volts, and then I'm going to check the open circuit voltage. So when I do this, I'm going to get a number down there. Try it again. There we go. I'm trying to build up the suspense here. And as you can see, it's a lie, right? We said it was going to be 64, and it's only 58. Now, why is that? Well, what was our temperature? Our temperature was, now it's saying about 49, 48 degrees Celsius. Well, let's kind of take that over here and take a look at what that means. So we're getting around, we're going to just call it about 50 degrees Celsius, right? And that's 122 Fahrenheit. Well, why is it so hot? Well, not only is the sun shining on it, but it's also on the roof, and the roof itself is really hot. And so what happens is, when I got the measurements, I want to say that we got a voltage of, do you remember, Ryan? Is it 54?
No, I don't.
Can you stop? Now we're going to come over and do a little bit of math. We found out that we didn't get 64.9 volts. Nope, we got 58 volts. Let's see if the math works out. I'm going to use 50 degrees Celsius because if you because of the wind, it was kind of bouncing around, and 50 is such a nice round number that I'm going to use it. And so what we're saying is what's the difference between the actual versus the standard test condition, which was 25 degrees, the standard test condition, right? So the difference between them is 25 degrees Celsius. Now our rule of thumb says that we're going to lose 0.4% for every degree Celsius. And so we're not losing one, it's not off by 1 degree Celsius, it's off by 25. So we're going to multiply that factor by 25. And when we do that, those cancel out. And if you remember, when we go to percent, we go 0.004 times 25. And what that's going to give us is a nice round number, 10%. I love that. So basically, we're going to lose 10% of our voltage because of the temperature. And so, and that's a negative, right? Because this was negative 0.004. And so we're going to go 0.01, that's 10%, times, well, what did we say the standard test condition was? It was that, right? So 64.9 volts. And when we multiply those two, we're going to get negative 6.49 volts, which I'm going to say is kind of like 6.5 volts. Okay? So what does that mean? It means that the temperature predicts that we're not going to get 64, we're going to get 6.5 volts less than that. And so let's see if that works out. 64.9 volts minus 6.5 volts. And when we do that, we're going to get 0.4 volts, and then what's that? 58. Okay, so 58.4 volts. And what did we get? You guys remember when we were doing the thing? We got 58 volts. And so, go ahead and bring it up here. So math works. And so what happens is when we're talking about the change in the voltage, we see it out here in the field. We see that when it's hotter, the voltage goes down, and when it's colder, the voltage goes up. And so I have this panel over here, and this panel has been nice and cool in just the ambient temperature, right? If I check the weather right now in Victorville, it's telling me it's about, I think 70 degrees or something here. And right now, this thing is showing around 10, 11, it's kind of bouncing all over the place, about 10 or 11 degrees Celsius. So when I go to slap this sucker on that roof, we're going to take a quick voltage on it. And what we should see is this thing is because it's a little cooler than standard test conditions, we should actually see a higher voltage than 64.9. Let's see what happens. Are you getting it?
Now I am. Good.
And if we wait a little bit of time, you're going to watch that voltage drop. Now, why is that voltage dropping? You see that? The reason why it's dropping is because this thing is sitting on this hot roof in the hot sun, and in time it's going to warm up to the point where it is like that one. It's 113 degrees Fahrenheit. It's really hot. It's 50 degrees Celsius. And as it does that, the voltage is going to drop. And so now we're down to 63, and it'll just keep going down, down, down. So what we've learned today is that solar panels will change their voltage output based on the temperature. And when we're out on the roof, it matters. The wind matters, the way it's set up matters, the color of the roof matters. If we had a white roof, the roof would be cooler, the panels would do better. If we had the panels above ground, you know, like a space, it matters. If the wind's blowing, when I was doing this experiment a few minutes ago, it was there was no wind at all, and of course the voltage was even lower. So hopefully this all makes sense. Thank you. We just did the temperature coefficient. We saw the two panels, identical panels, and they had different outputs, even though they're on the same roof and the same angle, the same sunlight. But the difference was one of the panels we left out in the sun for like a couple of hours, so it was totally hot, and then the other one we had it over in the shade, and it was nice and cool, and the wind was blowing, and it was like 15 degrees Celsius, and we ran out here and we slapped it on the roof. And as we tried to take the voltage kept changing because the panel's temperature was changing. And as the panel's temperature changed, the voltage went down because it warmed up. So now we have three panels out here. Now this one is the cool one that we brought out, and it's been out here for just a little bit. And you can see it's already at 25 degrees Celsius. So if I took the temperature right now, I should get, or the voltage, I should get real close to that 64.9. But when I look at this one, if you guys remember, it used to be 50, I think we said 50 degrees Celsius, and now it's at 53, and that's because the breeze has slowed, and so it's not getting cooled as much. And if we had a real still day, that thing would go up even more. And so now what I want you guys to look at is, you see this panel? This one is very different than these other two, right? And when we talked about nominal operating conditions, we talked about the difference that the design of the panel has on the temperature. So here's two panels. They're both out in the sun. They've both been out here for the exact same amount of time, but they're obviously different panels. And this one, let's take its temperature real quick, is now 56 because, like I said, the wind's died down and it's hot. It's not getting cooled by the breeze. Now this one is a different panel, and it's 54.6. So not a huge difference. Sometimes I've seen up to like 5 degrees difference between the two panels. But again, when they do the testing and everything, when you look at the data sheets, they'll have stuff that the nominal operating conditions. And they actually base the temperature on the design of the panel. And you can see this one has a lot more aluminum and white on it, and so it's going to be cooler. And this one, the cells are darker, and you can see the frame is darker, right? The frame, for aesthetics, they made them black because they look nice, but that black panel is also going to make it hotter. So just wanted to kind of show that to you. Again, you can feel the breeze is coming up, and the breeze is kind of making it where they're both being cooled off, and you don't see the dramatic difference, but typically you can see like a difference to degrees Celsius temperature panels. So we're looking at the impact of temperature on solar panels, and what we found out was that as the temperature goes up, the voltage on the panel goes down, and voltage times amps is power, and so thus the power goes down. So now what we did is, if you remember, we had a cool panel and we had a hot panel, and we had kept the cool one in the shade. Well, now we kept it out here on the roof long enough to where this panel and this panel are the same, within a degree, right? And so what we're going to do now is we're going to take these 2x4s right here, and we're going to put them underneath. In fact, we'll put it underneath the hot panel, the one that was a degree hotter, and we're going to lift it off the roof a little bit. And what that's going to do is allow air to go underneath the panel, and that's going to allow that panel to cool off. So through the magic of video, it'll be instantaneous, but we're going to lift it up and then we're going to let it set for a little while and cool off. In just a couple of minutes, and what we did, as you can see, really high tech here, we raised the panel up off of the roof. And this panel, if you remember, was like a degree cooler when they were side by side. I'm not sure why that was. But now we're going to compare them again. So we're looking at about 50 and 43. And so you can see that just by raising the panels off of the roof, we've cut a distance from the roof, and it's a lot cooler. Now, what's the ambient temperature out here? Well, it's about 20 degrees out here, Celsius. So it's in the 60s. And so one of the things to keep in mind is when you're up on the roof, the temperature up there is probably 20 degrees, maybe 30 degrees hotter than it is on the ground because of the roof and because of the sunlight that's hitting it. Now imagine if we were in like Palm Springs and it's 120 outside. What's it up on that roof? It might be 160, 170 degrees. And that's going to change the output of your panels. So in that kind of extreme condition, you might see your panels produce 20% less than what the nameplate data says. And on the positive side, if I was in Anchorage, Alaska, I might get 20% more because it's really cold, it's a breezy day, and a sunny day. So again, temperature, wind, how you mount them, they all have an impact on the temperature, and that temperature has an impact on the performance.